Assalamualaikum warahmatullahi wabarakatuh. My name is Amira Hatini. Today I'm going to present to you about our Mechanic of Materials project about railway bridge. Our company profile name is Innovos Construction STN.BHD. Project railway bridge from Pagoh-Muar. For introduction, our proposed project railway bridge from Pagoh-Muar, our group took inspiration for the design from Valankurkur railway bridge that is located in Finland that use Pratt truss as the design in their bridge. The aim for this project is to build a bridge that is structurally stable by using the Pratt truss design, allowing it to be used for a long period of time to make them suitable of being used in situations where bridge designer wanted to span long distances.
Assalamualaikum and hi, my name is Nur Amira Alia with Thailand. Okay, firstly is analysis for a beam. Okay, this one is live load. We get 566.67 kilonewton per meter square. Okay, for that load we get 127.288 kilonewton, and for total load, which is the sum of the total weight for all analysis beam table, which is 1021.84 kilonewton per meter. Okay, this is that table. The section is only one section because it's the main beam. Okay, the span is 2500, type area, material RCG25, size 1000 times 150, unit weight is 24, and we got the total weight is 9.
Okay, for the analysis of beam, for support column or pillar, the span that we use is 5000 millimeter. The type that we use is box beam, and the material that we use is RCG25. The size that we use is 150 times 200, and the unit weight that we use is 25. The total weight that we calculated is 3.75. The elastic modulus is 31. The elastic strength is 2.6. Total load column support times 4 that we get is 3.75 times 4, and we get 15. And for stringer, the span that we use is 2400 millimeter. The type that we use is box beam. The material that we use is RCG25, and the size that we use is 2400 times 1200. And the unit weight that we use is 25. Total weight that we calculated is 0.017. And the elastic modulus is 31, and the elastic strength is 2.6. Total load stringer times 6, 0.017 times 6, and we get 0.102. And for trusses, for section A and section G, the span that we use is 132.04 millimeter. The type, and for section B till section F, is 93.72 millimeter. The type that we use is box beam. Material is RC. The size is 32 times 286. The unit weight is 225, and the total weight for section A and G is 0.03, while section B till section F is 0.022. Elastic modulus is 31, and elastic strength is 2.6. The total load for both sides 0.17 times 2, and we get 0.34. And for trusses column, the section for section A and G, the span that we use is 132.04 millimeter, while for section B till section F is 93.72 millimeter. The type is box beam, and the material is SS304, and the size is 32 times 286. The unit weight that we use is the unit weight that we calculated is 78. And the total weight for section A and G is 0.094, and the total weight for section B till section F is 0.067. The elastic modulus is 2100, and the elastic strength is 504.7. The total load for both sides is 0.523 times 2, and we get 1.046.
Okay, Assalamualaikum. So my name is Siti Sharafana binti Suhaimi. My metro number is AN190096, and this is our diagram of truss. So our M is 25, R is 3, J is 14. So we use the formula M plus R equal to J to check either the truss is determinate truss or indeterminate. This means our truss is statically determinate truss. So from here you can see our free body diagram of our bridge. The total live load is 1025.11 kNm and our length is 24 meter. So we will multiply both of these to get our force, which is 24,602.64 kilonewton. So this is our shear force. So for point A, it will be 0 plus 12,301.32 and we will get 12,301.32 kN. That is for point 1. And then for point B, we will do negative 12,301.32 plus 12,301.32. So we will get 0 kN. To find the X, we will do 12,301.32 divided by X equal negative 12,301.32 divided by X subtract 24. And the final answer we will get X equal 12 meter. For bending moment diagram, point A we will get 0, which is 0 plus 1 over 2 multiplied by 12,301.32 multiplied by 12, and we will get 73,807.91. For point B, we will do 73,807.92 will be plus with negative 1 over 2 multiplied by 12,301.32 multiplied by 12, and the answer will be 0. So for point B is 73,807.92 and point B is 0. So the maximum shear force for our bridge is 12,301.32 kilonewton and our maximum bending moment is 73,807.92 kilonewton.
Analysis truss. This is the summary for the internal member force that we get from member BA till member MN. Next, this is the material that we use, which is reinforced concrete M40, and this is the cross section. The length that we use is 250 mm. The height that we use is 5,000 mm. The eccentric distance that we get is 166.67 mm. The modulus elastic is 35 GPa. The yield strength is 250 MPa. The radius of gyration is 2.885. The support and column is pin fits. For critical load that we got is 293.75 times 10 to the power of 4 kilonewton. The critical stress that we got is 170.5 MPa. The moment of inertia for IXX that we got is 2.604 times 10 to the power of 6 mm. For Z is 1.042 times 10 to the power of 7 mm. The allowable load that we got is 244.79 kilonewton.
Okay, next is determine required section modulus. Okay, we have this allow NM max, which is we got 20 MPa and 2.13565 times 10, so power and negative 3 kilonewton. Okay, this one is section of modulus. We got a section. One section is section A, which is 125,000, and AY is 31,250,000. Okay, divide divide of the value, we got 250 mm. Okay, next is moment of inertia. We calculate the S, the value of S, and also S rec or required. So we have to compare it.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf and I will present the discussion part. Okay, the main reason that we are given to conduct this project is to create a railway bridge. In making a stone structural bridge, the design concept for the bridge and the analysis data must be suitable with the proposing design that have been shown to all party members that is involved. Both the design and the analysis are important because they, in any way there are an error, this will affect the structure of the bridge. Overall, the approximate cost of the bridge has been recorded, that is 1,026,892 ringgit and 50 cents. This railway bridge costs the same as an average bridge but more eco-friendly. It is because that we have been informed to use standard material that is width 8,500 mm and length at 24,000 mm. Then, as we have done analysis the beam, the maximum shear force is 12,301 12301.32 kilonewton, and the maximum bending moment is 73807.92 kilonewton meter. Next, the maximum deflection checking is negative 1.1102 kilonewton. It is smaller than allowable deflection, that is 0.048. Analysis column section critical load. The critical load is 293.75 kilonewton. It is larger compared with allowable load, which is 244.79 kilonewton. Okay. The load is larger compared to the load needed for the column. We need to create a design as recommended that is not too much or over design because it will affect the column. Another design is that we can modify the column material so that the load can be supported by the column. Okay, next for the conclusion. In this era of modern technology, proposing a suitable design concept for the railway bridge is a very important process. It is because the design work must be ensure that the dimension is right and organized, as it will impact the research phase outcome. As stated, in order to have the suitable and stable design, we need to avoid over design that product design that do not meet one or more of the transparencies. Furthermore, and seamless criteria while construction more on the use of effective artistic elements that strive in increasing value appeal. Start to create non-complicated design and try to reduce the number of components in contrast to one that is good enough. Over design is insufficient and requires more time to create and accessible. By following this method, overall the cost of making such a brick can be reduced and can focus on building more safety base for all. Thank you. Hi again. I'm sorry, before I forgot, this is a sneak preview of our railway bridge in AutoCAD design. This is the plan from the top, this is from the back, and this is from the right, this is from the front, and this where we see it from the left, and this is how it look like is from view from the bottom. I hope this give a little share a little light on the design of our project, and thank you for watching our presentation video. Bye bye.